Lesson 3, interpreting and using function notation. So continuing on with what we were doing last on the homework, also on that warm-up was similar to this as well, using that notation. It says here's a graph that represents function f, which gives the height of a drone, dependent, right? Height of a drone in meters versus time it leaves the ground. So it says which function is greater, when f is 0 or when f is 4?
4.
Why?
At 4 seconds, it's higher up in the graph.
Yeah, at 0, it's at 0 meters. 4 seconds, it is at 1, 2, 3, assuming those are 4 meters as well. So 4 is definitely higher. Somebody else take number 2. Height of the drone at 2 seconds or height of the drone at 5?
Equal.
They're equal. They're both at 4 meters. 3?
3.
Okay, somebody else take the last one. The height at t seconds or the height 1 second later than that? Always gonna be taller?
No.
Yeah, that one actually depends on what t actually is. Over on this side, that would be the case. 1 second later would be taller. Coming down this way, that would be the opposite. So it depends on t. Question 2. Jackson, would you read it, please?
The function p gives the number of people in millions who own smartphones t years after the year 2000. What does each equation tell us about smartphone ownership?
All right, so t, the variable represents time after the year 2000. So what does each equation tell us here? So what year are we talking about?
27.
So in 2017, 17 years after the year 2000,
2,320.
and what is that? That's in millions of people.
2 million.
So 2,320 million, or we could just say 2.32 billion. Both are the same thing. People own a smartphone. B's kind of an interesting one.
In 1990, 0
0
people.
people.
When was the smartphone made? 2000?
Well, between 90 and 2000. I would say after 2000. At least enough so we could afford one. Okay, now it's the opposite. We're gonna write it. 2010.
T, parentheses,
P10, 10 years after 2000. So I need to write this number in millions of people.
how do you do that?
296.6 million would be that number, yes.
P15.
P15, 1.86 billion, so that'd be like our last problem. on the previous page where we had thousands of millions, and we changed it to billion, same thing. Maya's curious about the value of T in this. So what would T actually give you?
The year.
After 2000.
Years after the year 2000, in which, how many people?
But T doesn't give you that.
That would be 1 billion or 1,000 millions.
But T doesn't give you that amount of people.
Wait, 1 billion you said?
It gives you the year.
Yeah, T would be the years after 2000, in which 1 billion people, this is people here, on a smartphone. That is what T is telling you, number of years. She wants to know if 4 is a possible value
Yeah.
for this answer. So do you think 1 billion people?
No, but like, it got a pattern, I guess.
Yeah, so in 2010, it was 296 million. So do you think in 2004 that's a good estimate for
No.
1 billion? No. Just doesn't make sense. More people were buying phones. So if 04 was 1 billion and it didn't go downhill to 296 million 6 years later. Okay, using the information we have, let's sketch a graph. So let's plot these points that they gave us. So 17 and 2,320. Negative 10, 0. Ten and 296. $15 and 1,860. That should be all we need.
Yeah. What was the last one?
2B, 15 and 1,860. Just assuming that it's continuing to go up. So the Are You Ready says, what can you tell when we got 1 billion people? Well, we're not going to be able to tell exactly. I think it's safe to say it's somewhere in that area. So between 2012 and 2014 might be a good estimate. But you can't tell exactly from your graph. It is a sketch. And the final question we're going to look at then is the boiling water question on page 149. Connor, would you read that one, please?
The functions of using temperature in degrees Fahrenheit for the pot of water on a stove. agreement.
All right, we'll just work on it together. I'll do the first one, and then I'd like to take turns having you guys swap the bottom ones. So the first one, when I initially turn water on, or turn stove on, the temp is 72 degrees.
That doesn't make sense.
Maybe before you just
If this-
So my pot of water has 72-degree water in it.
Yeah, that doesn't make sense, cause you just, you haven't turned on the stove yet.
Well,
water is like.
water's not, what temperature is water when you can change it on your faucet?
I guess.
I mean, 70 is like room temperature water, right?
But you-
Water in here, water in their water jug, if they don't have ice in it, is gonna be about 75 degrees. So I don't think that's out of line.
Use it just a little.
I'm gonna go ahead and put that point right on my graph as well. Bless you. Just shy of 75. Who wants to take the next one? Go ahead.
Shoot. So, after the stove being on for 5 minutes, or wait, the longer the stove is on, the more, or the hot, or the greater the temperature is gonna be, so.
Yep.
5 is gonna be greater than, 5 minutes is gonna be greater than the temperature at 2 minutes.
Yeah, so I don't know exactly what it's gonna look like, but I know 5 minutes into it, it's warmer than it was at 2. Right, so that means your line's going up. How about C, somebody else? Go ahead.
After heating the water for 10 minutes, it's 212 degrees Fahrenheit.
And what's the significance of that?
It gives you another exact point.
What's 212?
Oh, is that what I meant?
Boiling point of water, yep. Okay, so this is going to increase until 212. Then what do you notice? What's the next one? Somebody else?
That when it's 15.
No, you're on D.
Oh, oops.
But it stays at the same
It's equal to.
temperature.
Yeah, it stays at this temperature for sure 2 minutes, right? So we'll go over to 12. So it's gonna be flat on top there for a little bit, staying at 212, temperature is equal. Somebody else?
Oh, when it's at 15 minutes, it's greater than 30 because they probably turned off the stove.
Okay, so 15 is greater than 30. So here's 15. So I'm gonna say it just holds steady for a while. 30 we know is gonna be less. How about this one? 0 is less than 30. So after 30 minutes, it's still gonna be higher over here, a higher temp than when we started. So however far you decrease, it's gotta be above this dot. So it's still cooling down after 30 minutes. And again, that's a sketch. Yours isn't gonna be perfect, but it does have to be increasing, does have to start here, has to be flat on top for at least 2 minutes. That last dot's gotta be higher than 72. All right, take a look at your homework. There are 7 questions. Just want to take a quick peek here. One being multiple choice, it appears. 2, explain. That's now one that is not multiple choice. Just kind of what we just got done doing. What do those mean? And what do those mean? Function notation for 3. 2 of them do go on to the next page there. 4, select all. 5 writes 3 statements. Notice it does say you must use the equal sign for at least one and at least one less than sign. So 3 answers there. So you're gonna be writing, you know, something like this. One has to be an equal sign, one has to be a less than sign, using that graph that's next to it there. 6 is a review from Unit 2, 7 is a review from Unit 3. So I don't think we have anything that'll give us too much trouble there, unless you disagree. All right. So that will be assignment due tomorrow.